that brings us to how IP address classes are handled. Now, classful IP addressing is kind of passé. It kind of fits the old model of doing things with IP addressing, and you'll find as you dig more and more into IP addressing that the whole class ABC thing isn't used as much, not like it was in the early days of IP, but it's still important to understand the classful structure of how IP was originally handed out. Really how this works is this, is that we have class A, which is the first portion, the first octet is the network portion, and then there's 3 octets of hosts. So as you can imagine, there's a very small number of networks, and each network has a tremendous amount of hosts. Really you're looking at, 16 million potential hosts on what would look like, if you initially looked at it, it would look like it was 255 possible networks. But there's a trick that we use to identify a Class A network by setting the first bit to 0. So we set the first bit to 0, and every remaining bit, 7 more bits, identify it as the Class A network number. It really means we could go from 0 to 127 as our valid Class A networks. The problem here, and this is kind of the short-sightedness of the people who designed the internet, is they didn't think about the fact that if we threw a few of these away and didn't use them, that it wouldn't have a huge impact. And the problem is they threw away the few of the very usable Class A addresses, thereby limiting us from having an extra 16 million possible hosts on the internet. For instance, the 0 network isn't used at all. It was actually pre-set aside for a broadcast address. Early on, we couldn't decide whether a broadcast address was all zeros or a broadcast address was all ones. So they took the first all zeros in the first octet and said, no, we're not going to use that, thereby limiting, again, 16 million possible hosts. Also, the 127 network was set aside for an internal loopback. That is, IP address communication from one process to another process inside the same box, so never actually touching a local area network or a wide area network. So if you see 127 addresses, in particular 127.0.0.1, which is used a lot, that's to usually communicate to the local host inside of the device itself. Now there's other 127 addresses that can be used if you have 2 separate or multiple separate IP stacks running inside of the same host that can communicate with each other using a 127 address. But because 127 sits in that Class A range, we again lost a potential 16 million possible hosts that could have gained that address if it was set aside as Class A. Now Class B, on the other hand, we take the first 2 bits, we set the first bit to 1, the second bit to 0, giving us 6 more bits in the first octet to set, and then the second octet, it's all network address space. So overall, the first octet is going to be a value between 128 and 191. So if you see the first field there, if you see that first decimal value and you see it between 128 and 191, or 191 at the maximum there, you know it's a Class B address. And by default, the first 2 addresses are supposed to be network, and the remaining 2 portions of the others, the remaining 2 octets, are supposed to be hosts. So for each Class B network, you could potentially have 65,536 number of addresses in the host portion. Now, of course, we'll talk about why you subtract 2. And you can see the number here of host count is 65,534. We're actually subtracting 2 for a reason of we need a network number and we need a broadcast number for the network. We'll talk more about that later. And then lastly, we have Class C. Now, Class C would implement a huge number of networks, but only a small number of hosts on each network, given the fact that we've statically set the first 3 octets to be network bits, and then the last octet, those last 8 bits, are set aside to be hosts. Again, notice that we've subtracted 2 of the values there for the host portion. We have a host count of 254 for a Class C network. Now, the problem with this classful structure is that early on in IP, what happens if you have a company that has, say, 1,000 users and they want to get IP address space? Well, it's kind of like the three bears story. It's this seat's too hard, this one's too soft, this one's just right. Well, in the case of a decent size company, not certainly a large company, but a decent size business with 1,000 users, they don't fit into Class C mold, and they certainly are way too, small for a Class B. So what they get? They got a Class B. So they were given a Class B address, and we soon figured out that as the internet started expanding very rapidly, especially 1994, In 1994, we all of a sudden realized that everybody and their grandma want to jump online and start sending email and surfing the internet. And we weren't set up for that. I mean, the internet wasn't, designed initially to do this kind of large scalability. We had to come back to our addressing scheme and realize that we made a mistake here and start grabbing back those Class B addresses that were handed out in order to better allocate the address space that we have within the internet itself. There was a lot of band-aids that were put in place early on, especially in 1994, to solve the rapid expansion of the internet. And if those band-aids weren't put in place when they were, we actually wouldn't be running IPv4 like we are today. So we'll talk more about that later, as we have a whole section on IP addressing, both in IPv4 and in IPv6 later on in this course.